All right, here we are, the first problem on the Unit 3 review assignments. We have a series of related rates problems here, and I'm going to draw a picture to start. So we have a wall, we have the ground, and we have a 15-foot ladder. And the top of the ladder is sliding down the wall, and I'm going to call this distance y, this distance x. And we're told that the top of the ladder is sliding down the wall at a rate of 2 feet per second. That's fast, isn't it? So dy dt is -2. So part A says, with what speed is the foot of the ladder sliding along the floor when the foot of the ladder is 5 feet from the wall? So basically the foot of the ladder has to be going away from the wall since the top of the ladder is going down the wall. And so they're asking us for dx dt. So this is a find dx dt when x equals 5. So this is a Pythagorean theorem problem. We have x squared plus y squared equals 15 squared. Differentiate it with respect to time. We're going to have 2x dx dt plus 2y dy dt equals 0. And then we were told that x would be 5. So we have to figure out what our y value is. And we need the Pythagorean theorem to do that. So we plug it into the Pythagorean theorem. We'll have 25 plus y squared equals 225. So y squared is 200, and y is going to be 10 rad 2. So coming over to my equation here, my differentiated equation, I need 2 times x, which is 2 times 5, times dx dt, which is what we're solving for, plus 2 times y times dy dt, and that is equal to 0. So I have 10 here. 2 times 5 is 10. I'll plug that, or I'll move it over to the right-hand side. No, I can't do that yet. Excuse me, sorry for my algebra. What I need to do here is multiply out this guy. So 2 times 10 times -2 is going to be -40 rad 2. Add that to the right-hand side. So I have 40 rad 2 equals 10 dx dt, and then divide by 10. So dx dt is going to be 4 rad 2, and our units will be feet per second. Part 2 of this problem says, at what rate is the angle of elevation of the ladder changing at that moment? Here is the angle that we need, this angle of elevation. So in order to work with this, we're going to use, let's do cosine. I'm thinking that cosine of theta will be x over 15. The reason why I wanted to do cosine is because they told us that at this moment x equals 5. So if I differentiate implicitly, cosine goes to negative sine theta d theta dt equals 1/15 dx dt. And I don't know what my theta is, but I can find it. So if my x value is 5, remember at this time my y value is 10 rad 2. The question is, what is theta? I think I can use arc cosine of 5 over 15 will give me my theta. So actually, do you know what? As I think through this, I don't even need that. I have an easier way to do this problem. So let's do that. I need sine of theta. Well, the y value is 10 rad 2 and the hypotenuse is 15. So I have -10 rad 2 over 15 times d theta dt equals 1/15. And dx dt, remember I got from above, was 4 times the square root of 2. So now I need to multiply that all out. Let me give myself some space here. Let's see, if I multiply both sides by 15 over -10 rad 2, this piece will go away. My 15s cancel, my rad 2s cancel, and I'm left with 4 over -10, which is -2/5 radians per second.